Alright guys, on this video I'm going to actually try to work each problem without actually solving it. I'm just trying to close doors and all that stuff right now. Hold on. Okay, here we go. So I'm going to just work each problem without solving it. I'm going to get to a point where if you have been paying attention in class at all, you will be able to solve it. Alright, so it says, a model rocket is launched from the roof of a building. Its flight path is modeled by h, where h is the height of the rocket above the ground in meters and t is the time after launch in seconds. What is the rocket's maximum height? So the key to almost all these problems is when you graph a quadratic, okay, it's going to be symmetrical. It's going to have a highest or a lowest point called the vertex. We're looking for the highest point in this case, all right? And it's going to be the vertex. It's an upside down parabola. It's got -5 as an a value. It's upside down. It's going to have a highest point. The way you find it is -b over 2a, and that's going to get you the x value. It's going to get you the x value of that vertex. It's going to get you this value right here. Okay, so looking at this formula of the rocket's flight, okay, of its height versus time, -b over 2 times a, 2 times -5 is -10, equals 3. So it reaches that maximum height in 3 seconds. So the vertex, let me zoom out a little bit. The vertex is reached, the vertex of this flight, of its flight, is reached in 3 seconds. And if you want to find the height, you take that 3 seconds and you actually plug it in here. So 3 squared times -5. Maybe I'll go ahead and answer this whole problem because it's easy enough to answer. So -5 times 3 squared, so -5 times 9 is -45 plus 30 times 3, which is 90, plus 10. That equals the total height. So that's going to be -45 plus 90 is 45 plus 10, that's 55. So it reaches a max height of 55 meters in 3 seconds. Okay, so that's the first one done. I'm not going to answer all of them like that because it's going to take too much figuring. So the next one. A rectangular field will be fenced on all 4 sides. There will also be a line of fence across the field parallel to the shorter side. Okay, there's a lot of stuff going on there, but just draw a picture. Okay, so we don't know how long or wide the field is. It just says rectangular field will be fenced on all 4 sides. There will also be a line of fence across the field parallel to the shorter side. Here's the shorter side, parallel to it. There it is. Done. That's fine. All right, so if 900 meters of fencing are available, what dimensions of the field will produce the maximum area? So again, we're trying to produce the maximum area. Area equals length times width. I'm going to take this field and I'm going to put it in terms of lengths and widths. So let's say I have 1, 2, 3 widths, and then I have a length covering from here all the way across to here, and then also the length on the other side, same length. So I have 2 lengths plus 3 widths equals, and I only have 900 meters of fencing to actually cover the two lengths and the 3 widths. Then I'm going to solve for one of the variables. I'm going to go ahead and solve for the 2 lengths. So solving it out, I have 2 lengths equals -3 widths plus 900 divided by 2. Length equals -3 over 2 width plus, not 900. 900 divided by 2 is 450. I'm going to take this now that I've solved for length, and I'm going to plug it into substitute it into the area equation. So my area is actually area. Now instead of writing length, I'm going to write what length is. Length is -3/2 width plus 450. So -3/2 width plus 450 times width. Multiply it out. This is my area equation. So I have area equals -3/2 width squared plus 450 width. Okay, and that is my area equation. If I'm going to, so it says find what dimensions of the field will produce the maximum area. So I need to maximize the area equation first to find that. What is the max area? So again, to find the maximum, just like we did above, you have this curve. Guys, this is just a junky, it's kind of a quick video because I've taught all these concepts on previous videos. So you have the curve, this is the area curve. If you're going to maximize it, you need to find the top point right there. That's the vertex. To find the vertex, it's negative b over 2a. Negative b over 2a. That's going to be the vertex. So negative b, negative 450, over 2 times negative 3 halves. That's going to be over negative 3. Okay, and that equals 150. So the vertex is found at 150. So the maximum area is when the width is 150. To find out what the actual maximum area is, I would take that 150 and I'd plug it into the W right here, and I would get my area. This is a point where I'm not going to answer this question. I don't know the answer. I'm not going to take the time to plug it into the calculator. That's what you would do. And then also, if you want to find the length, take the 150 for the width. You know that's, so width is 150. Area is whatever this would be when you plug 150 into your area equation. That's the area. And then the length is simply just taking the 150, plugging it into the width right here, and it says length is negative 3 over 2 times 150 plus 450. And that would get you the length. All right, going on to the next question. All right. Tickets at a school dance cost $4, and the projected attendance is 300 people. For every 10-cent increase in ticket price, the dance committee projects that the attendance will decrease by 5. Determine the dance committee's greatest possible revenue. So right now, to realize the revenue, or let's call it revenue. The revenue, you've got 300 people, so you got people being multiplied by price. People being multiplied by price. You have 300 people times $4 per person. So 300 times 4. Your total revenue at the moment is $1,200. Okay, so to figure out what the revenue could be when you increase price or decrease price or increase people or decrease people, you would simply, I'm looking for a black pen. Here we go. All right. You would simply say, okay, well, the revenue is going to be the number of people, which at the moment is 300. But for each price increase, the committee projects that the attendance will decrease by 5. So minus 5 people for every price increase, and X is representing the number of price increases. And then the price, I'm going to multiply that by the price. The price right now is $4. And then for every 10-cent increase, okay, so it's $4 right now, but for every price increase, I increase by 10 cents, so 0.10, so 10 cents. Multiply these things out, so that will be my revenue equation, and I'm trying to get the greatest possible revenue. So I'm trying to maximize this revenue equation. So I multiply it all out, so I got 0.1 times negative 5x, so I've got negative 0.5 x squared, 0.1 times 300, so I've got 30 plus 30 x, and then I've got 4 times negative 5, so I've got negative 20x, and then 4 times 300. Hopefully I did all this stuff right. I think I did, but I'm not certain. I'm going to go ahead and simplify it, or combine like terms, right here and right here. So I've got negative 0.5 x squared plus 10x plus 1200. And if I'm going to find the greatest possible revenue, it's the same idea. I'm looking for, here's the revenue curve, something like this. The problem is it actually starts at 1200. So actually, in all actuality, it might look something like that, okay, where this starting point is 1200. Again, doesn't matter. I'm looking for the vertex. And to find the vertex, to find the maximum on that revenue curve, it's negative b over 2a. So I'm going to do negative b over 2a. Negative b is negative 10 over 2 times negative 0.5, so that's over negative 1, equals 10. So doing 10 price increases, that's what that means. So this vertex is saying, with 10 price increases, I maximize my revenue to be something. And again, I'm not going to solve it for you guys. Take 10, plug it in here, and you'll figure it out. All right, but with 10 price increases. So the question is, now the next question, what ticket price will produce the greatest revenue? Well, if I'm doing 10 price increases, and for every price increase, I go up 10 cents, that means I'm increasing a total of 10 cents times 10, which is $1. So my ticket price, my new ticket price is going to be $5. $5. Okay, next one. Oh boy. Nancy walks 15 meters diagonally across a rectangular field. Well, actually, I want you guys to figure this one out. I think that this one, hopefully you guys can figure out as well. I might stop there on the video because I didn't want to record too much, and as you can hear, I'm in a rush. But if you don't understand anything or one of the concepts, guys, I've already recorded all the videos. You already know you can access each one of the topics. Just look at the dates, look at the topics, and find whatever you need to find in order to understand that concept. As always, I'm here early in the morning. Come in, and I can help you there also. All right, I'll see you in class.